Alright, 11.2, areas of triangles, trapezoids, and rhombi. Objective, students will be able to find areas of triangles, trapezoids, and rhombi. Okay, well, first off, let's do triangles. This is something we've done before, but the area formula for a triangle is area equals 1/2 base times height. And if it's a little bit easier for you, you could also just say base times height divided by 2, because those two things are exactly the same thing. Okay, next page. Alright, so before I do any of these problems, I'm just going to write my formula up here at the top so I can reference it. Area equals 1/2 base times height, and I'm going to just plug in these numbers. Alright, so I got an area I'm trying to find, and I know that it's going to be equal to 1/2. My base is 15, and my height, they tell me my height is 4, but I just want to explain something real quick about height. Height is always going to be perpendicular to the base. It doesn't have to be the bottom. The base doesn't have to be on the bottom, but the base and the height are always going to be perpendicular to each other. So, for example, you could get a triangle like this, and now look, the base is actually on top and the height is this way. That's okay because the height is perpendicular to the base. That can happen, and that's fine. You also might have it where the height is actually one of the sides of the triangle. And so, depending on how you spin this, right, you could actually call this the base and this the height if you wanted to. But it doesn't matter because they're both perpendicular to each other. And then here, sometimes you have triangles and obtuse triangles. You'll have heights that are actually outside of the triangle. See, this is the triangle here. And then these little dotted lines are just to show you, like, that this height is actually indeed perpendicular to this base. So anyway, when you go to calculate the area, you'll have plug in your numbers. 1/2 of 15 times 4. Well, 15 and 4 is 60, and 1/2 of 60 is 30. So you just write 30, and we were dealing with inches, so I'm going to write inches squared or square inches. And there's my answer. There's my area. So I think that you guys can do these 3 on your own. So give them a shot. Let me just warn you, though, that practice 1C, they're not trying to find the area. They give you the area, you're finding the height. So go ahead and try those, and I'll put the answers up here in just a second. Okay, here's the numbers you should have got. 1/2 of 6 times 9 is 27. 1/2 of 5 times 8 is 20. And for the last one, you would have plugged in 18 for your area and 3 for your base. I multiplied by 2 to fraction bust, get rid of that fraction, so I ended up with 36 equals 3h. Then I divided both sides by 3, and I got that h equals 12. Alright, let's go on to the next problem. Alright, here's the next problem. We have a quadrilateral, x, y, z, w. And they give us some of the segments of this quadrilateral, but they want us to find the area of a quadrilateral. And it's not a special kind of quadrilateral. It's not a parallelogram, and it's not just a rectangle. So it's going to be a little bit tricky to find the area of this guy, unless we can cut it up into 2 triangles. Notice we have a triangle here on top, and we have a triangle here on bottom. So that's what I'm going to do. I'm going to call this the blue triangle, and I'm going to call this bottom one the red triangle. And I'm just going to do it in 2 different parts. Okay, the blue triangle. It's the one that's pointing upwards. It equals 1/2 my base. Well, let's look. What's my base? The base would be xz, and they told me that xz is 39. And the height, well, the height would be yg, and they told me yg was 21. Alright, so I'm going to plug that in my calculator just a little bit. And the red triangle, that's the one pointing down, so that's 1/2. The base, well, it's the same base, so still 39. And the height, well, the height is actually going down now, which seems like kind of counterintuitive because it's height. But it's okay, because all that matters is that it's perpendicular to our base. And that would be HW, and HW is 20. Okay, well, now we just plug these numbers in our calculator. And for the blue triangle, we get 409.5, and then for the red triangle, we get 390. And so we just want to add those two together, and we would get 799.5. And they didn't give us any units, so we could just write units squared. And there we go. Okay, I think you guys can do the next one on your own. It's the same shape. We're using the same shape here, but we're going to give, they give us a little bit different numbers for x, z, hw, and yg. So go ahead and try that one. Alright, well, I got 216 for the blue and 202.5 for the red, added together, and we get 418.5 units squared. Alright, that's enough of triangles for now. Now let's talk about the area of a trapezoid. Area of a trapezoid with height h, bases b1 and b2, and we're going to try and figure out how could we figure out the area of this trapezoid. Well, the neat thing about the trapezoid is that it's actually two triangles with the same height, because if this is the base, this height's perpendicular, and if this is the base, this height's perpendicular. So these two triangles have the same height but different bases. So we could find the area of the first triangle by doing the base times the height, then divided by 2. And we can find the area of the second triangle by doing the second base times the height divided by 2. And then we could kind of combine these equations to get, hey, the height divided by 2 times the base plus base 2. By adding those two equations together, this is what we get. And so we can write that a couple different ways. One way we write that is area equals 1/2 height times base 1 plus base 2. Another way we get that is we would say area equals height b1 plus b2 over 2. Right? Those are both the exact same thing. They're just different ways of writing it. So you pick whichever way you like better. Alright, well, let's try it out on the next page. Well, this one says find the area of the trapezoid TVWZ. It gives us some vertices, so we got some points that we need to plot. Let's just remember what the formula is that we're going to use. It's 1/2 height times b1 plus b2. Well, I think our first step is going to be to plot these coordinates and then see if there's a way we can measure the height and measure both the bases, and then we should be able to calculate our area. So I think you guys can do this one on your own as well. So I would say first try and plot the points, and then if you get stuck, I'll have it up there in just a second. So go ahead and try that on your own. Alright, so if you plot your points, it should look something like this, right? You got your T, V, W, and Z plotted, and we could pretty easily count our bases, right? This top base just is 6 units across, so I'm just going to mark that as 6. And this bottom one, if you were to count it, you could see that it's 11 across. And then lastly, we just need to know this height. Well, the height from top to bottom is 1, 2, 3, 4, 5. So it has a height of 5. Alright, well, we're ready to find the area. Let's just plug all this into the formula. We know that the area equals 1/2 the height, which is 5, times the base 1 plus base 2. Let's just do 6 plus 11. Alright. Alright, so 6 plus 11 is 17. And then we have 5 and 1/2. And I'm going to just put that on my calculator. We'll see what we get. Let's see, 5 times 17 is 85, divided by 2 is 42.5. So, area equals 42.5. Again, we don't have any units, so we just write units squared. And there we go. And I'm actually going to stop this video here, and I'm going to make a second video so this doesn't become one really long file. So I'll make a second video that starts off with the area of a rhombus. So, see you guys later.